So hi everyone, in this video we're going to be learning how to do systems of three equations by substitution. Okay, so let me write that down. Okay, so it's similar to systems of two equations, except with this one we're working with one more equation and one more variable. That variable is z, okay? So here we have three equations. What we want to do first is solve for any variable. So usually you want to solve for any variable that has a leading coefficient of 1, if possible, because sometimes, you know, you're given problems where you're not able to do that. And so what I mean by that is, like, if you have, like, for example, the leading coefficient, for example, so if we have ax squared, a is your leading coefficient. In case you guys don't know what that is. So here we have a few. We have z, negative x, and a negative y right here. What I like to do is I like to just go on the first one and solve for whatever variable is only 1. So here we're going to solve for z on first equation. Okay, so we have 8x minus 2y plus z equals 6, or negative 6, my bad. And then we have negative x. So, okay, so we're going to solve for z. Okay, so we have minus 8x plus 2y, and then over here we have minus 8x plus 2y. We're going to get rid of this part so we can get z by itself. So we have z equals negative 6 minus 8x plus 2y. And what you want to do is you want to go ahead. Let me try to move this part here if I can. Give me 1 second, guys. I'm going to try to move this a little bit to the right. Oops. Okay, so we have z equals negative 6 minus 8x plus 2y. Okay, that's your new equation 1. Okay. And just separate. And then we're going to go ahead and plug this in. So 3, plug z in for equations 2 and 3. Okay, so these are your equations 2 and 3. This is 1, this is 2, this is 3. So we're going to go ahead and do that. So we have negative x plus 3y minus 2 times a quantity, negative 6 minus 8x plus 2y. And if you hear any background noise, I'm sorry, it's my sister. So yeah. So let's see here. So we have, and then, so this is going to be equal to negative 15, okay? So then what you do is you're going to go ahead and simplify this. So we have negative x plus 3y, and we're going to do distributive property, plus 12 plus 16x minus 4y equals negative 15, okay? And then you combine your like terms here. This is a like term, this is a like term, this is a like term, give me a second, and this is a like term, okay? So you have negative x plus 16x is going to be 15x, and then 3y minus 4y is negative y, plus 12 equals negative 15, okay? And what you want to do is you want to get rid of that constant there because you don't want it that way. So I'm going to do minus 12 on each side, and you have 15x minus y equals negative 27. Now let this be new equation 2. Because remember, we just plugged z in to this equation, okay? So this is going to be your new equation 2. And then, so we have 15x minus y equals negative 27. Okay. And then we're going to do the same for equation 3. We're going to plug z in. Okay. So we have 3x minus y plus 4z equals 13. Okay. So we're going to put 3x minus y plus 4 times a quantity, negative 6 minus 8x plus 2y, minus 8x plus 2y is equal to 13. Okay. So we have 3x minus y minus 24 minus 32x plus 8y equals 13. And then from there, you want to go ahead and do the same thing you did on the second one, which is this one. You want to combine your like terms. So here, a 3x, a negative 32x, a negative y, and an 8y. And you want to move your constant to the other side, but we're going to do that at the end. So we have negative 32 plus 3, that's like what? Negative 29x plus 7y minus 24 equals 13. Okay. And then So, and then you go ahead and you add 24 on each side, 37, so you get 37, and you're gonna bring this down. This cancels out. You get negative 29x plus 7y equals 37. And now let this be new equation 3, okay? So now you have number 4, what number 4 would be is so basically get equations 2 and 3, or rather, okay, so what I mean by this, we get, here, so we get negative 29x plus 7y equals 37. Give me a second. Okay. We're gonna get these two equations here, and we're just gonna, so we're gonna forget this part right here already. That part is done with. We now have a new linear system here, okay? We're gonna try to, so we're gonna bring it down. It's 15x minus y equals negative 27. Negative 29x plus 7y equals 37. Okay. So, we can solve this for y, so we can solve this for y. So we have 15x minus y equals negative 27. Okay. And this cancels out. We get negative y equals negative 15x minus 27. Divide by negative 1 on each side. We get y equals 15x plus 27, okay? So, we're going to plug that in for this equation over here. So we get negative 29x plus 7 times a quantity 15x plus 27 equals 37, okay? So we get negative 29x plus, and then 7 times 15, give me a second, is 105x plus 7 times 27 189 equals 37. And then we go ahead and simplify these two, so we get 105 minus 29 is 76. So you get 76x plus 189 equals 37. So then lastly, what you want to do is you want to go ahead and subtract. So solve this for x. We want, so minus 189 on each side. And then if I get my calculator, 37 minus 189, that's negative 152. So 76x equals negative 152. If I divide by 76 on each side, I get x equals, so 152 divided by 76, that's x equals negative 2. Okay. So then we can finally we have one solution. So we can plug this in to here. So we have y equals 15x plus 27. So y equals 15 times negative 2 plus 27, which is negative 30 plus 27, which is negative 3. So y equals negative 3. And then z, since we solved for it at the very beginning, we have z equals negative 6. Let's see, minus 8x plus 2y. So we have negative 6 minus 8 times negative 2 plus 2 times negative 3. And that's going to be equal to negative 6 plus 16 minus 6, which is negative 12 plus 16, which is equal to 4. So z equals 4. So your solution is, and make sure you always put your solution in like coordinate form. Your solution is going to be negative 2, negative 3, and 4. And that is your answer for this one.